Hello. Hi, my name is Rakendu, and I'm with Vince and Roman here. We're from Dialogic. We're going to be doing a demo about the advancements in MCU technology that we have been working on for the last couple of months. Just a little bit about Dialogic. Dialogic makes Power Media XMS, which is a media server, MCU. We do lots and lots of audio, video, WebRTC processing. We are IMS and WOLT compliant. It's a software-based offer, so it also gets virtualized. It can be deployed in cloud or ready-made COD server. So in terms of the WebRTC API support, we support a series of standard APIs, REST, JSR 309, WebRTC APIs, and so on and so forth, in addition to all the standard IMS APIs. So that's a little bit about XMS. So in terms of the standard MCU, when you think about standard MCU, typically there are a series of things that happens in an MCU, especially in a multi-party conference. And if it's video conference, it's even more complex. So there are things like decode that you need to do as a first step in the overall process, followed by mixing and then re-encoding. So this is very compute-intensive and complex process that happens within an MCU. So we've taken a look at it. So in this example, we have 6 different participants in a conference. So there are 6 different decodes, mixing, 6 different encodes, lots and lots of computation-intensive operations. And that tends to stress the server. So when you think about WebRTC, when you think about scaling WebRTC, where you need to do not peer-to-peer or one-person-to-one-person conferencing, but multi-party conferencing, this doesn't just scale. So what we've been working on is what we call efficient or evolved MCU, where we have looked at encoding operation specifically. We have, the data suggests that encoding is actually 4 times more compute intensive compared to the decode. So our focus was on reducing the encode cycle. So we have a couple of patent pending ways in which we do the encoder optimization, where we have cut back on the number of encode cycles, and we've seen a tremendous amount of performance improvement. So this is the kinds of results we're seeing. On a gigabyte bricks like this, which is a miniature computer, we're topping out at like 10, 15 video conferences. But with the evolved MCU technology that we've built in, we can take the same technology to 25, 30 odd WebRTC mixing conferences. And we're seeing something like 35% to 50% improvement in CPU. So enough of this slide where we're going to just jump into the demo, and we're going to show all that, how it works. So the first thing I'm going to do here is fire up my browser and then just join a video conferencing session. So what I'm doing is I'm just going to join a conference here, and I'm the first participant. So we are hooked up to a 720p camera here. I'm going to go ahead and then mute myself. All right. So what Vince and Roman are going to do is bring on additional WebRTC and also a SIP endpoint. So let's get that going, guys. Okay, so we got 2 people joining now, and this is the SIP phone that we have here. And what we're doing here right now is gradually loading different streams, and we're going to eventually load up to about 20 odd WebRTC clients. So the graph here is showing the fact that we are increasing our WebRTC participants in this conference. We have 1 SIP endpoint. We have 3 or 4 different WebRTC endpoints that are going right now. And I also wanted to show this view, which is measuring the CPU on the media server, which is running on one of these cubes, as we load up the box. So as you can see, we're already up to 10 WebRTC sessions and 1 SIP session, and on a relatively modest box like this, we are barely consuming about 25% CPU. Okay. So I think we got up to 15 WebRTC sessions now, followed by 1 SIP. And we'll eventually crack it up to 20. So essentially the point is we have found a way within Dialogic to optimize the MCU. MCU have in the past received criticism because they are compute intensive and they don't scale, especially in a video context. So when we have about 720p and 20 different art streams, we can show that our performance in terms of CPU consumption is about 30% now or something in that range right now. And we're still able to process the video at 720p with about, how many we have, like 25, something in that range, 21 right now. So that's the demo we wanted to show, just to show the advancements in the MCU technology and how it can work in a WebRTC mixing context. So that's what we have for the demo today. And also, in terms of some of the bonus here, we have put all the work that went into this demo on GitHub. Folks can download this from our GitHub repository. And we also have, for people that want to try media servers on Amazon, we also have a public image of the media server running on an Amazon cloud, which also shows the fact that the software-based media servers can function both on a small box like this or also in a cloud environment. So that's our demo. So thanks for your time.